Welcome back, student. In this video, we are going to discuss some more MCQs from chapter 2, that is polynomials. So, the question given to us is, first question is, if p of x is equal to ax squared plus bx plus c, then minus b by a is equal to. Here, ax squared, right, ax squared plus bx plus c is equal to 0 is the quadratic equation, standard form of quadratic equation. If you remove the 0 part, then it becomes the standard form of quadratic polynomial. And here, if we say if alpha and beta are the zeros of this quadratic polynomial, alpha and beta are the zeros of this quadratic polynomial, then we have seen from the relation between zeros and coefficient that sum of the zeros will be, sum of the zeros, that is alpha plus beta, will be equal to minus of the coefficient of x, that is b, is minus of b divided by the coefficient of x squared, that is a. So we have found the sum of the zeros of the quadratic polynomial, that is minus b by a is nothing but, minus b by a is nothing but sum of the zeros. So answer is sum of the zeros, question option C. So and let's see the product case. And if we find the product of zeros, that is alpha beta is equal to constant term divided by coefficient of x squared, that is c divided by a. So that's all for this question. Let's move on to the next question. And the question is, the quadratic polynomial having zeros 1 and minus 2 is. So zeros are given to us and we have to form a quadratic polynomial. And if we talk about the formation of quadratic polynomial, suppose the zeros given to us are alpha and beta. So let me show you the formation of quadratic polynomial. How do we form quadratic polynomials? Formation quadratic polynomial. That's it. It is nothing but x squared minus sum of the zeros of the quadratic polynomial, sum of the zeros into x plus product of the zeros, product of the zeros. This is how we form a quadratic polynomial. And let's put the values of the zeros. X squared minus sum of the zeros given to us as 1. Suppose it is alpha, let's take it as alpha, and let's take minus 2 as beta. So sum of the roots will be 1 plus minus 2 into x. And now product of the zeros will be 1 into minus 2. Okay. And on simplifying this, we can get x squared minus 1 minus 2 into x minus 1 when multiplied to minus 2 will become minus 2. And now x squared minus 1 minus 2 is minus 1, and minus 1 when multiplied to minus 1 again will become plus 1. So it will be plus 1x, that is x. And here it is minus 2. So the quadratic polynomial formula is x squared plus x minus 2. And here we can see that in option C, x squared plus x minus 2. So this is the answer. So now let's move on to the next question. Here the question is, the number of polynomials having zeros minus 2 and 5 is. How many polynomials can there be with zeros minus 2 and 5? For general structure of a polynomial, we write f of x is equal to a of x minus x1 into x minus x2 into x minus x3, and it will multiply it up to x minus xn term. But here, right, where a is not equal to 0, that is a can't be 0. So for various values of a, we can find a number of polynomials. Let's take some examples. For example, if we take a is equal to 1, we get x minus minus 2, that is x plus 2 into x minus 5. Actually, we are considering our alpha as x1 and beta as x2. So if we further simplify this, we can get it as x squared minus 3x minus 10. So this is a quadratic polynomial. And if we take any other values of a, for example, if we take a as 2, we can get f of x is equal to, this was actually f of x is equal to, so f of x is equal to 2 into x plus 2 into x minus 5. On simplifying this, we can get it as 2 into x squared minus 3x minus 10. X minus 10. When multiplying it by 2, we will get it as 2x squared minus 6x minus 20. So this way, for various values of a, we can find infinite number of polynomials. Infinite number of polynomials can be found this way. So this more than 3 option will be the answer. So that's all for this question. Let's move on to the next question. The product of the zeros of 3x squared plus 11x minus 2 is, we have the standard form of quadratic polynomial as ax squared plus bx plus c, and here we have to find the product of the zeros. And for product of the zeros, we have seen, let me write, product of zeros is nothing but c by a, and here we have to find c and a, that will be the answer. And as you can see here, 3 is coefficient of x squared, that is a. Let me write, a is equal to 3 and c is equal to minus 2. So the answer is minus 2 divided by 3. So option B is the correct answer. So this is the answer. So that's all for this question. Let's move on to the next question. The number of zeros for the polynomial y is equal to p of x if the graph meets x-axis at 3 points. Number of zero of a polynomial actually depends on the number of times the graph meets x-axis. Number of zeros depends on the number of times the graph meets x-axis. So let's take an example. Let us plot a graph. So this is our x-axis and this is y-axis. Suppose this is the graph. Here you can notice that in how many points the graph meets x-axis. This is one point, this is another point, and this is another point. So in 3 points the graph meets x-axis. So number of zeros will be 3 in this case. Let's take another example. This is x-axis, this is suppose y-axis, and this is the graph. And here you can see that in no point there is a graph which does not meet x-axis. So number of zeros in this case will be 0, nada. Let's take another example, x-axis, y-axis, and this is graph. And now here you can see that in 2 points, let me mark the point, this is 1 point and this is another point. In 2 points the graph meets x-axis, so number of zeros will be 2 in this case. So answer will be 3 since the graph meets x-axis at 3 points. So option A will be the correct answer. So that's all for this question. Let's move on to the next question. If alpha and beta are the zeros of the polynomial, then the sum of their reciprocals is. So in such case, we will find the zeros first. And for this particular question, we can say that it is a quite simple equation, so simple expression, so we can find the zero first. And then we will find the reciprocal of the zeros. And then we will find the sum, actually, sum of the reciprocal. So reciprocal sum will be the second step. So let's find the zeros of this quadratic polynomial. So 5x squared minus 7x plus 2 equal to 5x squared minus x plus 5 plus 2, and here it is plus 2. And here we can see that the product of 5 and 2 is 10 and sum of 5 and 2 is 7. So 5x squared minus 5x minus 2x plus 2. Now we can take 5x as common, so it will be x minus 1, and from the second two term we can take 2 as common, it will be 2 into x minus 1, and minus and minus 1 multiplied will become plus. Oh sorry, it was minus 1. Let me change it, minus 1. That's it. Now can it's now x minus 1. Okay, now simplifying it, 5x minus 2 into x minus 1. So from here we can find x as 2 by 5 and 1. So the zeros are 2 by 5 and 1. Now if you find the reciprocal of them, so let's write their reciprocals. The reciprocal of 2 by 5 is, actually we are finding sum of their reciprocals. So reciprocal of 2 by 5 is 5 by 2 and 1 is 1, and adding them we can get this as 5 plus 2 divided by 2, and it is nothing but 7 by 2. So 7 by 2 is the answer. And that's all for this question. Let's move on to the next question. The product of the zeros of x square minus 15 is, this given expression is actually a quadratic polynomial, and here ABC, distinguishing between ABC is quite critical. So let me write it again, x squared minus 15, and if we write it according to the standard form, it will be x squared minus 0 x minus 15. Now we can clearly see that which one is A and which one is B and C. So it will be A is equal to, here A is equal to 1 and B is equal to 0, and C will be equal to minus 15. Now the product of its zeros will be C by A, and here C is minus 15 and A is 1. So minus 15 itself is the answer. So here option A is minus 15, so that will be the answer. Now moving on to the next question. A quadratic polynomial whose sum of the zeros, a quadratic polynomial whose sum of the zeros is 3 and product of the zeros is minus 2 is, we have to find the quadratic equation, sorry, quadratic polynomial. So we have the general structure for forming a quadratic polynomial as x squared minus sum of the zeros, and we are taking alpha plus beta as sum of the zeros, into x plus product of the zeros, that is alpha beta. And now x squared minus sum of the roots, that is alpha beta, is given as 3 into x plus product of the root is given as minus 2. So plus into minus minus 2 will be minus 2. So x squared minus 3x minus 2 is the required quadratic polynomial, and option D is the correct answer. Let's move on to the next question. And it is, if p of x is equal to g of x into q of x plus r of x, and this is nothing but the division procedure. In long division we have already seen that if we divide a polynomial p of x, suppose this is the, let me write, p of x is a polynomial. If you divide it by g of x, which is another polynomial, and we get a quotient q of x, another polynomial, and sometimes we get non-zero remainder or sometimes zero remainder r of x. In this given question we are given degree of p of x is 6 and degree of g of x is 3. Then what should be the degree of q of x? It is 3. And ask me why. I'll say, let's take an example for getting a better picture. Let me show you. Suppose if we take an example as p of x is equal to x raised to the power 6 plus 3x to the power 5 minus 4x cubed plus 2x squared plus x minus 1 plus x minus 1. And if we divide it by another polynomial, suppose the polynomial is x cubed plus 3x squared minus 1, x cubed plus 3x squared minus 1, then what we will get as quotient? And we need to make x raised to the power 6 here, and for that we divide it by x cube and get a quotient x cube again. But how? X cube when multiplied to x cube becomes x to the power 6. Do you remember the formula x raised to the power m into x raised to the power n? How can it become x raised to the power m plus n? So this is what we have used there, we have used here. So degree of quotient of x in such case becomes 3 again. So answer is 3 for this question. Let's move on to the next question. And the question is, which of the following is a polynomial? Very simply, we can see that option V, x squared plus 2x plus 9 plus 19 is the answer. But why not the other cases? Let's have a quick look at that. So in the first case, 1 divided by x squared plus 2x plus 19. Can we write it as equal to 1 into x squared plus 2x plus 19? But whole thing will be raised to the power minus 1. Since exponent of variable can't be negative for being polynomial, so this will not be a polynomial. So that's all for this. Next one. C. Suppose this is also for the same case, we can write it as x plus 19 raised to the power minus 1. So for this same case, it cannot be a polynomial. And the next one, square root of x plus 19. Square root of x can be written as x raised to the power half plus 19, and power of variable can't be a fraction, that must be a whole number. So B is the answer. That's all for this chapter.